Problem 2 is multiple choice, but before we look at our possible answer selections, what I want to do is I want to just investigate what we already know, because there's a lot that we already know, even though this looks a little bit different. So let's just look at this function, but we're going to break it down into pieces. So the whole function is y is equal to the absolute value of x plus 2, and then on the outside we have this plus 3 hanging on. Okay, so let's just break this into its parts. So we've looked at this type of problem before where we have y is equal to the absolute value of x plus 2. The only difference is that we might have some number here. Okay, so we know that our center point is right here, but it's opposite. So we know that our center point has to be where x equals -2. That's our center. And we know that from looking at absolute value problems on a number line. Okay? So the only thing is that we don't know what the distance is. Our distance is represented here by y. Okay? So we don't know what that is. So all I know is that my center has to be where x is -2. Okay, so let's look at what else is happening. We have this plus 3 over here, so let's just pretend it's y equals the absolute value of x plus 3. Well, we know from the previous problem, problem 1, that when this was the absolute value of x minus 4, that minus 4 right here gave us a vertical shift down. So I have some high suspicions that this plus 3 must do the same thing. That must be a vertical shift down. Okay? So, looking back at what we have and using what we already know, this here must be our center where our x equals -2, that's our center, and then this here must be our shift down. So when we're going up and down on our xy coordinate grid, we're talking about values of y. So that plus 3 must be what y equals. So that means our vertex must be at -2, 3. Okay, and in fact that's what it is. So let's look at which one it is, and I'm going to show you a calculator trick. Okay, so we're looking for one that has a vertex of -2, 3. So here we go over, that's -2, oh that's -3, that's not it. This over here, well that's not it, because I want to go -2. Here I go -2, move this down a bit, -2, 1, 2, 3. So this must be the function graph of that particular function. Okay, so what I want to do is I want to show you the calculator. I'm going to show you how you can do this on the calculator. My calculator just told me that the battery is low, so hopefully it will last for what I'm trying to show you. Okay, hopefully you can see the screen. Looks pretty dark. Might not be able to show you. Trying to get the light in there just right. There we go. Okay, So what did I do? I went to the y equals on my calculator up here at the top. So if I push this y equals, and I get this y equals stuff going on here. Okay, so now I'm going to put in my function. I have to put in absolute value, and the only way I can do that is I have to go and I have to push my math screen. So I'm going to push my math screen, my math button, and then I'm going to scroll over. So number is highlighted, and I see number 1, it says absolute value. That's what I want. ABS stands in math for absolute value. So now I'm going to put in what's inside the absolute value. And what was inside the absolute value? That plus x plus 2. So I'm going to push my x key, which is right here, x, and that's going to put x inside, and then I'm going to do plus 2, and then I have to close the parentheses. Now these look like parentheses, but what it's doing is it's telling the calculator that this is absolute value. The calculator is just not advanced. The more advanced one would have straight up and down lines. Okay, so if on this one it's not showing you that, I can show you it on another calculator in a later example. So this is the absolute value of x plus 2, and then we need to add 3. So I'm going to put plus 3. Okay, so now the magic happens. I'm going to push the graph button, and it graphed it for me. So look at that. So now all I need to do is I can take my calculator and I can compare what's what. And then I can see that, if my lighting were a little bit better here, I can see that the vertex is at -2, 3, which is the same as this one right there. So that's my answer.